Okay, hey everyone, I'm Mohit, and today I'm going to be talking about how we can use deep learning to understand transitions between different panels in comic books. This is joint work with Varun, Anupam, Yogarshi, Jordan, Hal, and Larry at the University of Maryland College Park. So what exactly do I mean by these transitions? Here we have two panels. On the left, we see a man taking an axe to another man's head. On the right, we see a zoomed-out shot of a skyline at night, punctuated by the text of a scream. We can all infer the violent action that no doubt occurred in the space between these two panels, which is also called the gutter. Human readers are able to make coherent stories out of panels such as these through a process called closure, which involves making connective inferences using common sense. We'd like to computationally model this process. However, before we can do so, we need a data set. We collect one in 4 steps. First, we download 4,000 comics in the public domain from an online repository. Next, we extract 1.2 million panels from these downloaded pages by training a faster RCNN on our own annotations. In the third step, we extract 2.5 million dialog boxes from these panels by training another faster RCNN. Finally, we apply Google's OCR service to the dialog box images to get machine-readable text, which we can then feed into our models. Now that we have a data set, let's look at some tasks that explore closure. We look at the closed-style framework, so we give a model 3 panels of context and ask it to predict some aspect of the 4th panel, such as dialogue, artwork, or which character said what. For example, here are 3 panels of context from an old Alice in Wonderland comic. We see on the left that Alice and her friend are flying around on some cloud-powered vehicles, but Alice's cloud malfunctions, and on the right, she ends up crashing into a building. Now, given the artwork from the 4th panel, the text close task asks the model to predict which of these 3 candidates best fits the blacked-out dialog box. I'll give you a few seconds to read over and make a selection. Okay, the correct answer here is C. The incorrect choices A and B are randomly sampled from panels on the same page as this one, which makes the task difficult. For example, candidate A contains the named entity Alice, and so to make a correct answer, a model has to properly understand the context. Speaking of models, we use a hierarchical recurrent architecture to solve all of these problems. In the first level, or the intra-panel network, we extract features from the artwork using a CNN, and learn representations of the dialogue using an LSTM. We combine the two in a feed-forward layer and feed the result to the next level, or the inter-panel, which is an LSTM that goes panel by panel and integrates information across the context. The final hidden representation is used to score dialogue candidates in our text close task, artwork candidates in the visual close task, and combinations of dialogue in the character coherence task. Now let's take a look at some results. I just wanted to give 2 quick highlights from this table. First, both modalities are important. If we look at the text close task, we see that a model that looks just at the artwork or just at the dialogue performs far worse than a model that has access to both modalities. Second, human performance far exceeds that of computers on all 3 tasks that we look at. To discuss our theories on why this gap exists and how we can improve computers on comic understanding tasks, come talk to us at our poster. All of our code and all of our data are available at that GitHub link below. Thanks so much.